Magnifique. I will not speak in French to you. I am sorry, but I'm not sorry. Because it would be horrible, horrible for all of us. All right. So thank you all for sticking around. Give yourselves a round of applause. Yay! All right. Thanks to our organizers. This has been super fun and super informative. And so I'm going to try to act. So my plan today was actually a step before Ethan's talk, in a sense. So even though Unreal 5 is the new hotness, and it's about to be the new hotness, but it's not yet, right? Unreal 5 is still very much in beta. It's kind of scary right now. So it's not an engine you should ship with or think of actually releasing a product with. Unreal 4 is very stable right now. It's been around for a while. It's on version 4.27.2. So it's well understood, and there's lots of amazing things we can do with it before Unreal 5 comes out sometime in 2022. So right now, what I'm focusing on today is I'm going to show you the basics of getting running with an Unreal project in Unreal 4. You could, if you are following on your own machines, you can use essentially any version of Unreal 4. 4.2.7.2 is the latest. I'm actually running 4.2.6. Doesn't matter. It's all fine. And what I'm going to focus on today is both I'm going to actually introduce you to how the really basic concepts of that programming interface that we saw, not meta sounds, because meta sounds are in the new version, but the basics of just blueprints, just navigating that interface, running a test project, and then in this case, how you would set up a project with open sound control so that you could then hook that to a dynamic audio programming environment, like Pure Data, which is what, in this case, I just threw together a little PD patch to demonstrate. So again, Pure Data is open source. You could, in theory, receive OSC messages into Super Collider or Chuck or Max MSP. So if you have those, you could use them as well. Should work just fine. So, how's this gonna work?
No.
The mic's on or
No. Ah, yes.
Yeah, I was gonna say that might be better, rather than me trying to. I could sing. Romantic singing. Where'd you go? All right. Oh, that's gonna be a little better. That's a world I can understand. Hopefully we can get rid of some of the rain if I position it just right. There we go, look at that. Oh, wow. All I have to do is try to speak French and people laugh. I like this. Great, okay. So first things first, if you're following at home, or here, this is Unreal 4, and this is the launcher. So for those of you who are familiar with playing Fortnite, this is where you play your Fortnite. You go to the library and you pick your games and you play Fortnite. Oh, actually you can only click on that, but that's fine. You can see all the games that I've downloaded for free but never downloaded, right? I play Journey, that's about it. If you haven't played Journey, we should just do a whole talk on that. So the Unreal tab in here, you can see the versions I have installed. I actually have them installed on an external hard drive because, as someone mentioned before, they're huge. So Unreal is very big, takes up a lot of disk space. Today, what we're going to get through some stuff. We're not going to get through everything. Time permitting, in general, I would take much longer to go through this. Probably 2 courses in the 2 days in the course that I teach on this material. So what I did today was I threw together a project and I mentioned this earlier, I stuck it up on my website. And so you can get to this, it's either robhamilton.io. I think it redirects here still. Let's see if I paid my bills. Oh, that's a good question, maybe I didn't. Oh, I did, okay. robhamilton.io or homepages.rpi.edu/hamilr4. So the first one, it's a little easier. And right here, this is going to take you to a Google Drive where I tucked in this demo baller, which is our demo project, which has everything in it that we're going to cover today. So regardless of how far we get, at some point I'll shift into high gear and just show things, but you'll already have the project.
So how do you go to the Google Drive?
So here there's a link called, on my website, robhamilton.io.
Okay.
There's GRAME workshop right at the top. I hacked my own awesome HTML. And if anyone wants any of the videos that I was showing earlier in the project, they're all on my website here, including a bunch of others. So full versions of those things I breezed through super quickly. So if anyone's interested, stuff's here. You can find all kinds of fun stuff. Cool. Any questions on that? Good? Thumbs up? Please don't hesitate to raise your hand, shout out a question if something isn't clear. If you guys don't get it, it wasn't worth doing. So let's keep that in mind. So in the Epic Games launcher, this is a few things. So I'm using this project, Demo Baller. That's the one that you guys are downloading or can download. So what I'm going to do first is I'm just going to launch a clean project because I want to show you just 3 quick settings that you might want to change. I see a bunch of you are on Macs. Macs are great. I love a Mac. I use it all the time. Game engines are optimized for the video cards on our PCs right now, right? So this has an NVIDIA 1070 in it, which is like last gen, but still pretty good. In particular, Epic doesn't like or didn't like supporting Mac video cards because they weren't powerful enough. So one of the settings I'm going to show you is how just to degrade your graphics to make it run better if your machine's a little slower video-wise, even if it's just an older PC. So in this case, I'm just going to, this is kind of a similar interface to what we saw with Ethan's stuff. I'm going to create a new project. You go to Games, create a new project. Again, if you're downloading my project, you don't have to do this. I'm just showing you how you would. And go here, and in these templates, you can choose. The one that I'm using is this roll the ball project style thing, rolling ball, I guess they call this one now. So I'm just going to click that. Gives me a bunch of project settings here. For now, I typically leave most of these. This will actually take up a lot of disk space if it throws in at high quality and if I did allow this starter content. So I think that's good that I didn't do that. Let's see, sure, I'll create this. I'm actually going to leave this as is. The first time you launch a project, it might take some time. In general, whenever you open a project, especially in Windows, if you click on it and you don't see anything happening on your screen, it still might be loading. It takes a while sometimes, the first time you run the engine in particular. So if you click it again, it'll actually load 2 instances. Now that's bad for 2 reasons. One, in that you have 2 versions of the game running, it's take up a lot of CPU. The other is you can't save. And you won't know it because one of them will be backgrounded. So it happens, trust me, especially on Windows if you're less familiar with it. This is a super clean project right now. We're going to have to do 2 things, and one of them is exactly the question I asked Ethan that I wasn't sure about, and you would have to restart your project. So I'm going to show you that real quick. We're going to use Open Sound Control. I mentioned that before. It's a protocol for streaming data. It's like open source MIDI. Anyone here familiar with Open Sound Control? You guys have seen this before? I see some heads. Okay, great. So one of the great things about this is that Aaron McLaren built OSC directly into Unreal. So the native OSC is no longer an external plugin, which is great. Super helpful for these kind of projects. In this case, we need to go to our plugin settings. So edit menu, plugins, where we can choose all these tons and tons of plugins to add to our system. In this case, if I type in OSC at the top, we'll see a couple things, but it's this one here, OSC Open Sound Control. You can see by default it is not enabled. We need to enable it for this project in order for it to show up in our selectable code. So we're going to click Enabled, and then you'll see at the bottom it says Restart. You have to restart the project. So we will have to do this. So this is, if you're loading my project, it's probably already saved. If you're starting from scratch, you would have to do this. So
how did you went to the story?
it's okay, I'll do it again. I clicked restart, but I've already loaded on the system, so it's going to come pretty quickly. So in this case, what I did was I went to the edit menu, and at the bottom of that you see plugins. And so I click on plugins, and I type OSC in the search menu, and then it will come up. Now we see that it's enabled on my machine.
Okay, OSC. Which one?
The one that says OSC, Open Sound Control, not Open Module, OSC Modulation Mixing. So that's our first thing. Now we're OSC enabled. We can actually code with OSC. It's great. Works really well. Two things I wanted to show you real quick. Settings-wise, just to make your lives easier. If you go, so this is the IDE, right? We have a view into our 3D scene. We have at the bottom a browser, essentially our file browser for the game. On the right, we have a thing called the World Outliner, which is essentially all the objects in our scene currently as text references. That's all this, and so any object here in the scene is actually showing up here as a text reference. The details for every object here that I will select and parameters can be modified within this scene as a global scene can be edited down here. So we're not going to do too much of that today. I think there may be one thing that we're going to do. But that's what we're seeing right now. And then when we want to add new actors like primitive cubes or lights, things like that, we can use it from this pane on the left. It's kind of the basic view of what we're looking at. And then along the top window of the window here, we have access to a few things. Play button when we want to run our level. By default, I can actually run this, this project is set up to taking UI control or GUI, keyboard control, and a whole bunch of stuff's already set up. So I can already run the project. I can hit escape to close it down. The settings that I wanted to look at really quickly, if you click on the settings tab here, if your machine is not crazy fast, if you scroll down to this engine scalability section settings, you see on mine all the settings are set really high. Epic, which I guess is the best because Epic makes it. If you were running this, if you're building an Android app, for instance, you would degrade all of these to low. If you're running on a PC with a weak video card, it might make sense to do that. Now, if you do that, some of the shaders might have to be recompiled, but you just wait for your machine to chug through it, but now then your system will run a lot better. So that's the first, and you can do a shortcut, click these buttons at the top, just scale everything down. So there's that I wanted to set, and then one weird setting that will be helpful in this case, and I wrote this down in this little document, which is actually in that same drive link. This was just some notes I made. When you Alt-Tab out of Unreal, to go to another app, like in this case we'll have Pure Data running, we might want to go back and forth. By default, it slows down the game engine when you move away from it. Usually it's not a bad idea when you're doing development. In this case, if you have two apps running simultaneously, it's a nightmare. Like you want to be able to see what's happening. So in this case, we can actually disable that process. We do this in Unity also. There's a flag in the player settings in Unity like that. So in this case, we're going to want to go to the Editor Preferences, General Performance. See if I can remember that. I usually do this once and then forget about it. So I wrote it down so we can remember. Here, let me do this side by side, we can see it. So I'll go to the Edit menu, Editor Preferences, so the third from the bottom. Oops. There's then under this General Settings. Unfortunately, there's tons of these kind of menus in Unreal, so it feels a little overwhelming sometimes, but we'll get through it. There's this General set here, and then there's a subset called Performance. We're going to click on Performance, and what we'll see there's the Use Less CPU when in background. So that may be set by default for you. If it is, turn it off. Like disable it like this. We don't want to use less CPU when the app goes to the background. We want to let it run so that it doesn't slow down and chug. Does that make sense? Awesome. And that, again, I just wrote that here. There's another setting that we don't actually need in this example, but it's a good one when you do this kind of work that I listed here, where you can actually, when you're using sound assets, you can allow them to run in the background when you Alt-Tab out. So, but we're not going to do that today. Cool. All right. So those are just some things I wanted to make sure that you guys could see, so that when we're doing what we're doing, things work. So this is your fresh project. I'll show a few things here, and then I'll actually open up the project that I shared with you, which has all the code in it, so we can move faster. The programming environment, there are two ways to program in Unreal. You can program in C++, which is great if you're a C++ developer, right? You can do everything that you know how to do. If you're not, and you enjoy workflow programming languages like Max MSP, Pure Data, take your pick, they have a really wonderful scripting engine called Blueprint in Unreal. And so in this example, for instance, if I look through the world outliner, you can see the type of all these different things in here, right? We see these cubes, they're just static meshes, right? They don't do anything, there's no code associated with them. But a few of them, we see that these are actually blue links. These are actually blueprints, and that's our player, our ball, right? Our physics ball. It's one of them. And if we look on the right, it lets me edit that. Edit physics ball BP, meaning blueprint. It's the name of the blueprint. Similarly, the sky has one, but that's just by default here. So in the content browser at the bottom, we actually see a folder called blueprints. In here, we'll find our friendly ball. And so any code that's associated with the ball is going to be tucked into this blueprint. So I'll double click on it. And now we see something, another window pops up, but we can dock it up here. Keep it all. Nice. This is a great engine if you have 2 monitors. It's a little tough if you have 1. So in this case, I'm now looking, and again, there's tabs and panes always in Unreal. You'll get used to it, but it's a little confusing at first. Right now, I am inside the blueprint for our ball, our physics ball blueprint, and we see there are these 3 small tabs here. So right now we're looking at the event graph. This is essentially at runtime. This is the code that's going to run. And these boxes we see, this is how you write comments. So any big box you see like this with a little bit of text, that's just a comment. Like you would label your code in kind of a top-down traditional programming paradigm. Red objects are events, things that trigger. They can either be in response to a mouse click, data coming in over the network, or they can be kind of system calls like begin play or tick, the tick event that runs every frame in your game. Those are the 2 primary ones we're going to look at today. There are many more. And if you're familiar with Unity, these are things like the start event or the update event that you have in any C# script that you'll create. So since this is a demo project, they already have some code in here. And the code in here associated with this ball blueprint is actually input control data. We see move forward, move right, jump, touch input if we were using a touch screen, and an event that triggers when the ball hits the ground. Now, most of these, you might want to say, well, what is move right? Right now it's set to the WASD keys to move around, kind of traditional game paradigms. But that's all set up with an input script, or an input manager. Where is it up here? Play with this a while. Project settings input. Is that right? Where is it? Yeah. So in the edit project settings input, just showing you where this is. We're not going to change any of this. But under input, we actually create, instead of saying use the D key to go right, and we connect D to the code, we connect an abstraction of that called move right. And then in this menu, you have this in the newer versions of Unity too, right? We can actually assign the key to map to that event. So it's a more generalized event. We can have multiple different things to move right. It could be a joystick move right. It could be a keyboard press. It could be a touch event. So that's what's happening. So that's just what those red events are in our blueprint. We're not going to change any of this for this example. Just letting you know so that when you see it, you're not just wondering what the hell's going on, which happens a lot in these environments. Questions? Awesome. Cool. So in this case, I'm just going to shut down this baller and open up my baller. No, I don't need to say that. It's fine. Which is the one that you can download. And if I go back to my Epic window, I will see demo baller. And for me, this is going to launch in 4.2.6. If you launch it in 4.2.7, that's fine. Or 4.2.5. I had to put everything on this
So
external
do you
drive.
need to download all the folder or just, yeah?
So, if you want to download my project, this is this, oh yeah, sorry. I tried to zip it, but this machine which I brought with me didn't actually have a zip utility on it. So if you just download that downloadable folder as a zip file and then unzip it, that's the whole project, that's everything you need. Right, I forgot about that. Thanks, Windows. No more freezing. All right, great. So, I'll just close all that. So here we are now, same world, all right, exactly the same looking thing, but now I actually added some code. And we're gonna just step through how we're gonna take our some basic data and ship it out from the environment over Open Sound Control, and then use it to control anything we want. I also added code that can receive OSC messages in here. We'll look at that, time permitting. We'll look at it all, but we may not be able to go deep into all of it. And there are internal synthesizers built into Unreal, which are pretty cool. There's a modular synth, there's a granular synth. These are mostly built by Aaron McLaren, whose name we've heard a few times already today. He did some really cool stuff in Unreal about a year and a half to 2 years ago. And that's all going to continue. So I made a super basic example using that. So great. Let's see, where to get started? Okay. So we saw the blueprint for our ball here. We could write a whole bunch of code in our ball. That would be fine. I'm going to do a few things in this environment though. I'm going to take the position of our ball and I'm going to track its X, Y, and Z coordinate and I'm going to send that out over OSC. So I'm going to get that data every game tick and ship it out from Unreal. I'm also going to track, I think, this cube, the one on top, because I can actually crash into it and make it fall. In that case, I'm going to track its rotation, see how it rotates as I knock it around. And I think there's something else I'm going to track. So in this case, if I was just tracking data about this ball, I could throw my OSC code into the ball's blueprint. That would make perfect sense. In this case, the ball doesn't really know anything about this cube, right? It doesn't have a link by default to where that cube is. So if I wanted to keep that code in the ball, I could do that. I would have to give it some way to see this. It's like in Unity when you have one script can actually connect to a script in another object. In this case, however, my examples can be really simple. So I can do something that's kind of nice. This level has its own blueprint, which is called the level blueprint. Pretty straightforward. We access that by going up to the blueprints menu here, clicking on it, and we'll see open level blueprint. So I'm actually going to throw all my code in here. And the reason for that in this example is it's pretty straightforward, and the level can see all of these things. I'm not doing anything fancy, so the level can see the ball, which means it has a reference to it. The level can see the cube, so it has a reference to it. So I'm going to write all my code in the level blueprint for this example. So you can see I already wrote some code. So this is all in here. And I'll unpack it, don't worry about that. So,
how do you get here?
Sure. No, it's not a problem. So again, back at the, when we're looking at the level, we go up to blueprints, click on that, and we go to open level blueprint.
Okay.
And we get windows popping up over windows, and some of them don't background, so it's nice to type them in. Again, 2 to 3 monitors, fantastic for Unreal. Really helpful.
So it shows me, sorry, but the blueprint is empty, so I need to select something.
Well, if you created a new level, if you create the new level, if you guys didn't download my example, will be blank. The one I uploaded has data in it, unless I totally screwed something up, which is possible. I didn't triple check it, I guess. Did anyone download mine?
Yeah, I used the one we downloaded.
And there's nothing in it?
No. But maybe I'm
Okay. Well, I'll download it in the background because we're going with the assumption that I screwed something up, which is always possible. It's definitely possible, but let that down as I'm talking. So in this case, I'm going to step you through just some basics here. Jan, what time should we probably aim to finish now?
Let's hope that we still have half an hour.
Okay, so 6:45 total. Okay, very good. So I mentioned before that these red nodes are events. So the two primary ones that if you have a blank blueprint that you should see there, and they'll be grayed out, but you can still use them. We'll see begin play, which runs at the start of every time I hit the play button. So that's essentially code, a place where we can initialize things, initialize variables, initialize references to objects in our code, and then the tick event, which runs at the speed of our graphics processor, essentially. So think of this as running continuously, frame by frame by frame by frame. Again, like the update function in Unity, and begin play like the start event or awake event in Unity. It's a good way to think about it. So I have two sets of code here. If we look kind of, again, since this is a workflow programming environment, these white lines are essentially the workflow, so to speak. So we can trace, Max MSP and Pure Data go from top to bottom, Unreal Blueprints go from left to right. So we can track, in this case, all the way to here. I just created a big obvious visual chain of what's happening. If I was trying to be a cleaner coder, I would have encapsulated these things as functions, perhaps, which we can do. I'm going to show you how to do it. You literally just grab your code and right-click on it and say collapse to a function, and it will dump that to one tiny node. But by keeping it all obvious like this, it's a little easier to wrap your head around the first time. So I'm going to first, I'm going to move everything down except for the initialization, which is where I'm going to start. And I will go back real quick, and check that I actually did not screw up, which I very well may have. Come on. You can run multiple Unreal projects side by side if your machine can handle it, it's fine. Go to blueprints, level blueprint. Yep, it's got stuff in it.
So, I will tweak and restart.
Okay, I'm happy to come look too. It's a workshop. We don't stand on formality. Here at GRAME, we don't. So I'll move everything down here except for kind of the initialization stuff. And again, this is essentially an infinite workspace. You can just move stuff around as you want. So when I'm, when I hit play, I'm going to need to do a few things here. I want to get access to my ball. I want to get a code reference to it here in this blueprint, so that I can get data from it. And I may want to get data from like my keyboard presses, for instance. And then I'm going to go and create a reference to the OSC client, set things like the IP address and port. I'll come back to all this and just scrolling through it quickly. Create a message that I'll then populate with data, right? I'm just creating objects at this point, this initialization. And then I'm actually going to create a server that will run continuously, that will receive OSC data. And so that's essentially what I'm doing at the start of my gameplay. And so I'll just look really quickly at how we're doing all these things. Over here on the left, by the way, are things like variables that I can create, just like you would create variables at the top of a text-based script. And you can tell by the different icons that these are different data types. Things like pink is a string, green is an integer, or green is a float. Green's a float, isn't it? And blue is some kind of object in this case in general. And I'll show you how to do all that. And then again, so these nodes that we see in Unreal, in Blueprint, I can create them by right-clicking anywhere on the background, and I get this menu. And I could either go through this massive list of categories. If I wanted to get a driver from the Magic Leap device, for instance. These are all the functions that are associated with these things. For input devices, like we heard, I can get, for instance, values from a gamepad. Just like any programming language like this, you eventually learn what the objects are that as you learn the syntax of the language. So when you start to learn a few of them, you can just type in the name at the top and it will bring you there, which is kind of where we're going to start. In this case, I wanted to get a reference to our ball. Ethan actually did exactly the same thing. He got a reference to what they call the pawn. The player pawn is kind of one way that one object that can delineate your character. There's another one called player character, but in this case, I'm not using it. So in this model, in this demo template, the pawn is our ball. So from any blueprint, I can make a request to the engine and say, give me the player pawn. By default, there's an index value here of 0, and it's going to say, I'm the only player in this game. It's not a multiplayer game, so I'm going to leave it the way it is. And out the right of this, actually, this returns that value. So there's a kind of a strange relationship in directions in these blueprints, right? The trigger data flow essentially flows left or right, and then some of these objects, they kind of pull off to the left, and it feels a little confusing at first sometimes, but so essentially what's happening here is I have a chunk of code that says, get me a reference to that player pawn, and then from it, I can create an object. In this case, I need a reference specifically to the blueprint. Just kind of detailing how this is. We'll move faster eventually. In this case, I can say, I'll need to cast this. So the player pawn is just a generic object. I can say cast to, and in this case, we see physics BP, ball BP, which showed up. That was my blueprint. So that will give me access to the custom code that's stuck in that ball if I want it. So in that case, these two objects work together. So this outlet here on the right, this is a reference to my ball with all of its glory and all of its code. If I want to be able to access that from anywhere, I can set it to a variable. And we'll see this over and over in this example. Right here, I can just drag off and let go, and the menu will pop up, and it will give me essentially context-sensitive code that I might want to use. So here, you see it says promote to variable. So if I'm too lazy to go over to the variables menu on the left and create a variable, I could just do this, and it would create, see, I already did it, so it's going to stick up on there, but it would create a variable here, and I could change its name to, I don't know, monkey, right? Maybe. Sounds like a good variable name, but no. I already created one called my player pawn, so I'm just going to use that, but that's how I would create a variable if I was doing it right now for the first time. So we have a reference now, this variable. We see it over here, my player pawn right here. And if I want to use this anywhere in my code, I can just drag it from this variables list, click get, and it will appear as an object. And now that is my pawn. I can use it from anywhere. So that's the paradigm of how we actually grab data from places, store it in variables, and then access it later. So we'll use that over and over and over again in these patches. So remember, we're just instantiating our variables right now. We're making these references. So you see this here. I'm making lots of references to the player pawn, to the controller, storing them all as variables. The OSC plugin that we initialized, if I type in, I go to this menu and I type OSC, we'll see all these kind of OSC specific functions that weren't here before we enabled that plugin, which are super helpful. They're exactly what we would want to use in this case. In particular, I need to create a client, which means OSC output. And if I wanted to, so I could do this, create OSC client or server. Server means I'm going to receive OSC data. So I click the client to create this, which gives me this object. Now this object, if you're familiar with Open Sound Control, right, I can tell it. So this is just a nice trick. The documentation says you can leave this blank and it will receive messages from any IP address. It's not true. Doesn't work. Just throwing that out there. In this case, I want to receive data from this machine, or at least it doesn't work in this example. I want to receive data from my same machine. So if you're on a Mac, you'll often type localhost, because you're familiar with networking, or you can type in the address 127.0.0.1. That's your standard localhost IP address. Windows doesn't love it when you type in localhost. It's supposed to, but it doesn't. So I typically will always type in 127.0.0.1 if I'm doing localhost on Windows machine. Just throwing that out there. It's supposed to work. The other piece of data here that I'm going to populate is the port, which again, if you're familiar with Open Sound Control, the port is essentially a window into my networking, and I'm telling the computer this port number, this unique number on my machine, which I'm just choosing 6006. Because I usually use 6666 because I think it's cool, but it totally doesn't work on this Windows machine. I have no idea why. I don't know what's blocking port 6666. I always use that port. So here, I'm just using this port, works fine. So if I send data from pure data, I'm sending data out. So I'm going to send data to my local computer, 127.0.0.1, and I'm going to send data to port 6006, which means in pure data, in my case, I'm going to listen on port 6006 and get that data coming in. So that's a pretty standard OSC data streaming paradigm. The rest of this I don't need in this example. And again, we'll see the same thing here. Once I created my OSC client, I save it to a variable, which sticks it over here. And if I just drag off here, I don't have to worry about making sure I select the right variable type. I just click promote to variable, it will automatically type things for me. I don't have to say float or string or integer or OSC client in this case. So now I have a reference to the OSC client, which I will use very soon. I'll start with that, right? We'll come back to the rest of that stuff in a second. First thing I want to do is I want to get data. So let's just say we've initialized that, right? We've started the game and now our client is there and we have a reference to our ball in here. So on tick, on this event tick, I want to now start getting data from my player. In this case, I can just use that variable that I populated, my player pawn. I don't have to go out and find it again, right? I already have that reference. Any data in that blueprint for that ball, I can grab here. So I can literally just drag off here, and like you can see here, there's a Boolean variable in there called can jump. And I didn't create that. That was part of the control data that we saw. I can just, if I start typing in can we see, I can get it or I can set it. So I can access that variable or I can change it from here. So the data that I want from this, we actually see right here. So these graphs are a little tricky to wrap your head around at first. I understand that. So if something's not clear, please raise your hand. Remember, the white workflow is essentially time, the order of operations. So the colored data is essentially variable data that's being populated, and then when it finally merges with one of the white lines, we're essentially engaging that data. We're setting it, we're getting it, we're manipulating it in some way. So in this case, the simplest thing that we wanted to do was get the XYZ coordinate location of our player pawn every single game tick and update that. So I take a reference to my game player pawn. In this case, I can say there's a function called, I can get its location, I can get its rotation, or I can get its transform, which is both of those things. So if I just typed get transform, for instance, I'll see a whole bunch of options here. What I actually want is the world transform. So again, you just get used to the way that they name all these things, just like in any language. So there's probably other ways I could have done this too. In this case, yeah, so if I said get world transform for the ball, since it's getting this from the pawn, if I go look at my pawn, we'll actually see there's a ball, a camera, because the camera's associated with it, and some arm that connects to it. I don't care about that, I care about the ball. So if I just click on the arm, it's going to not only get me that get world transform object, but you see it's actually going to, retrieve the right component for me. Now there's two ways I could do this. One, I could actually get the ball, or when I did this previously, I grabbed what's called the root component of it. In semantics, you don't have to worry about it too much for right now. That's essentially the physical coordinate tracking component of it. So this function will get me the transform of my object. Transform is colored orange in this case, and it is a lot of data in there. X, Y, Z, pitch, yaw, roll, scale in 3 different dimensions. There's a couple ways I can get that data. One is I can pull off here and create an object called break transform, which then will break it out into the location, rotation, and scale. Or there's this cool little feature that you can do. You can right click on the node and go to, oops, I missed it somehow. Right click on the, oh, it's because it's not, you disconnect it first. I right click on the node. When it's not connected, I can do this thing called split struct pin. We'll actually break that into its composite components. So now the transform is represented as the location, the rotation, and the scale. Each one of these has 3 values in them, right? So I could do the same thing if I really wanted to. I could break apart now the location. So now I have X, Y, and Z. It's still all the same. It's just essentially exposing the internal variables of that construct, of that structure, so to speak. So I've already done it. There's another way that you can do it. You can use an object called break transform, and I used that initially in this case. And I did the same thing. I exposed the X, Y, and the Z data here. So I grabbed, this is my player location, X, Y, Z data for our player pawn. This is going to be used every game tick, and I'm going to do something with it. So if we trace this line back, I'm going to do 2 things. One, I'm going to print it to the screen. Why? So I can debug it, so I keep my sanity and know that it's working. The other is, I'm going to add it to a struct, a structure that's going to store all the data that I'm going to send over Open Sound Control. So in this case, I made a custom structure. Not something you have to do, it's just a little cleaner. And so to keep as an example for you all, this is kind of a nice way to do it. A structure is just a data, it's like a class, right, that encapsulates a bunch of data in this case. And if I go back to my content, right, my content browser, I made a little folder called OSC, it's right here. And if I go in there, I created a struct. And the way that I did that, just to show you how, I right-clicked here, and Ethan did this at some point in 5, and it lets me create all these different kinds of objects, right? I can create a blueprint class, which we have here. I'm not going to do right now. And in this case, sorry, I forget where I did where. Oh, blueprints, there it is. Yeah, so under the blueprints menu here, the bottom entry here is a structure, right? And that just essentially lets me make a composite data type that stores a bunch of different things. So if I create that, it'll create a new empty structure here. If I double click on the one I made, you see I put a string, I gave it a name. You can store the name, the X, the Y, and the Z coordinates, the pitch, the yaw, and the roll, and the height that my character jumps. This is just so that I can encapsulate my data in one place, and then when I'm finally ready to send it out, I just grab it all from the same spot. not necessary, but clean, I guess. And so I could have added my own, I could add a variable here by clicking on this button, a new row would appear, and I could add whatever I want. So, again, I know I'm moving quickly, but in that case, so we see this object over here, this structure. This is like adding a class in Unity. So I have a class that my engine can see, and so now I can access that struct from anywhere. And we're going to see that in this blueprint. So I call that OSC data output, because that's what I'm going to use it for. In this case, I can populate that with a function called make, type. In this case, the name of my struct, and you see it's even, calls it, categorizes it as a struct in this menu. So here's all that data that I kind of set up, and I'm just dumping all that data into it every game tick. Similarly, I'm so I've got the location of my pawn, X, Y, Z. The next thing I'm going to grab is the data from that cube I pointed at, the one that's on top I'm going to crash into and make it fly around. Now, in this case, I need to get a reference to that cube. Well, this is where me coding this in the level is super easy. So the level can see that cube, it's just sitting there, and that cube doesn't have any code, it's not a blueprint, it's just a primitive object. So if I go out to my level here, I can click on any object here, anything. They're all static mesh actors. And if I leave that highlighted and go back into my blueprint, my level blueprint, I can now right-click and create a reference to that object. So that random block that I had selected, I just right-clicked and created a reference to it. So if I wanted to change its position or delete it in code, I now have a reference to it in this blueprint. So the cube that I want to grab data from, just as easy. I just selected on this, I came in, I right-clicked, I created a reference to it, and now I can do the same thing. I can get its rolled transform. I could have gotten its rolled position, or I got its transform, and I just thought it would be fun. Let's grab the pitch, yaw, and roll. So the rotation of that object at every given frame, and we'll dump that into our structure. Similarly, I have a variable here that's tracking how high my character jumps that I populate up here just from the same player pawn. That's just a piece of data that's already being stored over there. So not super important. I just wanted to show a couple different ways that you can grab data in this example. So populate that into the structure. I set that to a variable because it's always good to have variables to reference these things later. Cleans up your lines too of your cables. So you can see this can get messy very quickly, just like PD patch or max patch. Basically, I'm going to grab all the data from my structure. I'm going to break it. It's the terminology they use. And I'm going to print that out. And so this is just a way to print it all in one string. So let's run this really quickly and we'll watch all the data print. And to keep things clean, I actually added a trigger. If I hit the P key, it will print the screen. Here, let me, my window is tiny. Bring it up. There you go. So there's my core, there's all that data that I'm populating in the structure. It's being printed to the screen in real time, right? So I know it's working. It's an easy way to debug in real time. So great, I have all the data I want. Let's send that out over OSC. So I could delete all this now, but I tend to leave my debug in there until I'm really done. In this case, I need to create an OSC message or an OSC bundle. Those of you familiar with OSC, those concepts should be pretty standard. An OSC message is one single message that you're going to send out every frame. A bundle is essentially a package of individual messages that are all stuck together and sent out at the same time. In this case, we're doing it very simply. We're just going to create a message. In order to do that, first I had to create an object of type OSC message, which I did back up. Whoops, I slid it all off the top, right? I did that up here in our initialization sequence. I created an OSC message, assigned it to a variable. So now that object exists, I step through every piece of data in my struct that I stored, and I add it to the message sequentially. First, I gave it a random name. There's just a hard-coded name in there. So I add the string, and then the output of that goes to the next node, and I add a float. That's the X, Y, Z coordinate data. I add the pitch, yaw, roll of that other object, and I add the jump height. So you can see the chain continues, right? So I've added all the data to a single message. This is all happening, this is one tick, right? And so now that message is ready to be sent. And I already created my OSC output object in that initialization sequence. And I now just call a function called send OSC, right? And I send it using the client that I stored as a variable, and I send the message that I stored as a variable. And this function does it. It sends it to the target IP address and port. Now, in this model, since there's one object, one message that I'm reusing, very important that once I've sent it, I have to wipe it, right? So I don't just keep appending data to the same message, but grow and grow and grow and grow. It's a mistake we all make. So at the end of my tick, I clear out the message and we start over. We roll right back to the beginning. So let's just see that sending data to PD really quickly. Any questions on that as I launch pure data from somewhere on my computer? And I will say running audio programming software on Windows is horrible. Chuck, I usually would just test my OSC output in Chuck. Chuck is run miserably on Windows right now. I'm not sure what's going on, at least in my machine. So this is, I think this is the right file. Where is this? Let's make sure I'm grabbing the right version of the file. I have it's on my external hard drive here. Windows, J4, Workshop. Here we go. So I made this amazing PD patch, right? I know you're all in awe of this beautiful code. So in this case, simple OSC script, I'm going to receive on port 6006. Sounds familiar. In PD, in this case, this data is going to come into binary format, which is the binary flag, and so I need to then convert it to a human-readable format, in this case, and this is just how we do it in PD vanilla. I'm not using anything external. And then I formatted essentially so that I PD prepends the word list onto any list in the actual data, so I have to trim that out. And then I'll see a namespace, which I forgot to point out. I actually called it PAW demo/ball. That's the namespace I created over here. I'll try to jump back and show it real quick. And I strip out the namespace, and then I'm left with just the list of data that I sent. So let's look at that super quick, and then we'll hear it. And then we'll, at a minimum, we've succeeded in something in this incredibly fast run through. Let's see if I actually can get sound, because this is PD, which means I need to manually set this to, which is this one. What could go wrong? This is where I would say, everybody hold your ears, right? I'm playing. Well, actually, I play sound at this point. No, it's turned off. Let's see. You are set to print. You are set to play. There we go. Yeah, there's some data. Let's get these on the same, right? Since we went through the trouble of making it so we can alt-tab out of the engine without slowing down, let's get these side by side. Here's our data in PD, which is already slowing down my computer because it doesn't like writing in real time. And so now all that data, and I can show them both just to, right? We're seeing all that data stream out of Unreal into pure data, and I can use it pretty easily. So let me just fill this real quick, right? This is just the data with the namespace stripped out. We see X, Y, Z, pitch, yaw, roll. I think I clicked something else extra, and this last one is the jump height. So in this case, now in audio land, that's just data, right? I can use it to drive anything I want. This is where the artistic sensibility of the technical musician comes into play. How do you convert data from one paradigm, one modality, which is, in this case, a ball rolling around, and turn that into something musical or creative, or just sonic, however you envision it. I, of course, envision that as 3 sine waves, which is the greatest sound known to man, I think, right? And so in PD, I'm just going to take the XYZ coordinate of our ball and connect it to 3 oscillators, and we're going to just enjoy the beautiful music for at least a second. So if I run that one more time, yeah, see, that's where it gets fun. Let me turn it down. It's part of the joy. There we go. Right? It never gets old, does it, right? So I literally can sit and do this kind of stuff for hours, and it drives everybody around me crazy, but, you know. And so this is a mapping with no forethought, right? I did not sit here and plan how I would do this and help make it musical. I just connected it essentially a proof of life demo, but it's still fun. I'm not going to lie to you. And so in that case, that's the most basic connection you can get from something like Unreal to pure data. I would say it's relatively straightforward, but it's not. These workflow programming languages are incredibly tricky the first time you look at them, right? Everybody knows that. The first time you looked at Max or PD, what is this? What is this strange thing? But you start to learn the environment, you learn the basic set of objects that you need to use, and you start expanding on that. Same paradigm for working with something like Blueprint in Unreal. So that's, I mean, at most basic, that's essentially what we're doing here. Jan, we're at 6:46. Should we, I mean, I of course could go on for 2 more hours. Everything is in this patch. I'm happy to go on for longer, but I understand we don't have all that freedom, so.
Well, you can maybe close the door and make like I don't know, frankly, oui, je pense qu'il nous attend, mais okay, so let's
Okay, great. Cool. So, any questions on that basic interaction, right? That's our bread and butter. We're using data in a virtual environment to trigger sounds in an audio programming environment. Very natural for artists. Anyone not shipping a commercial game, you're building an installation, you're making a musical piece, a live interactive performance, works great, right? So the flip side to that is, how do we receive data into Unreal from something like Pure Data? And so I mentioned before that in this, in our initialization sequence, I created an audio server. So the concept is exactly the same. Create OSC server. You know, again, I typed in the 127.0.0.1 IP so that it doesn't do strange things. I told it to listen on port 6004, different port ID, because in Open Sound Controller you have to lock the port essentially, so you have to have a different input and a different output port. And the only other thing I need in this case is to click this Start Listening button. I could do this dynamically. I could run code that would trigger this when I hit a button to turn it on or off. In this case, I just want it to start as soon as the game starts. So it's always listening. Server's always listening. Save that to a variable so I can access it. This is where things get a little tricky. Think about what's happening. I have this game engine running, and whenever a message comes into the computer and hits that port, I want it to do something. So I'm no longer working off that game tick. I'm not on tick, I'm not checking to see if a flag has been set that says, oh, a new message came through. Because that would get out of sync very quickly. Because there's not, data flow coming from OSC is not synchronized to the game tick in any way. So in this case, I actually want to create my own event. An event that will trigger, again, a very standard programming paradigm concept. When data comes in and hits that port, it will trigger an event in Unreal, just like my keyboard press triggers move right or move left. And so in that case, I use an object called bind event. So I drag off of the variable from my server, and I say bind, I guess written away, bind event. So in this case, bind event to on OSC message received. Makes sense. Whenever an OSC message is received, trigger an event. So it creates this object, and then this is a little weird, even in the Unreal programming paradigm. With this object, I then drag off the left of it and actually create the event. So I type create event, which I learned this from Google at one point, right? Just like everything else. I create the event. Oh, I just probably broke everything by doing that, so I'll have to undo it. And in this drop-down box, I said create, I think I said create matching event. I think maybe since I did 2 of them, it messed it up. So anyway, in that drop-down, I created the event on OSC message received, which means another one of those red boxes appeared. It appeared in my script. Where did it go? Since I did this previously, it didn't appear again. Here it is, down here. So this wasn't here before, on OSC message received. This didn't exist before I created that. I dragged off to the left there. But this is a custom event. I can call it whatever I want. Again, I could call it monkey. If you ever work with me, I call everything monkey. I don't know why. And so now, whenever OSC data comes into port 6004, this event fires. Exactly the same paradigm as tick or any other of these events. Or like, as you see right above it, key press number 1, which is what I'm doing for triggering this ugly synth sound. We'll hear in a second. And so when that comes in, I set, a message comes with it, right? It's the inverse of what we just did. So this is a message filled with data coming from PD. This is the address it came from. And this is the port it came into, which I misspelled here, port. And so from that, I can extract the data that I want. And I'll do essentially the reverse process that I did previously where I added data to the message. I can get the address from it if I want, and I can print that as a string. And here I actually have a series of functions. I can get, the way they let us access that data, if I go back here really quickly, so here's the message that was created when that came in. I drag off to here, I can say get OSC message. I can't type. And you see these are my options. I can get a float, so it's typed. Ethan mentioned this a few times. This data is typed, so I have to say get me a float, or get me a string, or get me an integer, or get me a Boolean. I can't just say get whatever is at the first piece of data. I have to say which kind of data. What they do to allow us to generalize is I can get all of the floats from a message, right? If I want, because that's one type. And so it scans through the message and looks for data tagged as a float. And I can get all of the integers. And it will return me an array of all the floats, or all the integers, or all the strings. Or I can grab individual ones if I know that at index 0, there's a string, right? Because I sent the data. So if the data is known to me, I could just say, there's a string at index 0, there's a float at index 1, there's an integer at index 2, get me those 3 pieces of data and type them accordingly. So in this example, I set up an example both for you. I retrieved, where was it? Somewhere in here. Yeah, here. I get OSC message string at index because the first piece of data I'm going to send is a string. I set it up that way. So that's the function that I use at index 0. And then the rest of my data that I'm going to send from PD are all floats. So I just said get me all the floats. And just like any programming language, I would then iterate through an array. For each item in this array, do something, right? Here, it's exactly the same thing. I can do a for each loop. And what that means is every index of the array will trigger a message here, and it will keep looping through this block of code here. It'll keep looping through this for every item until it's done, and then the workflow will continue out this bob. It's just, that's their paradigm for loops. Just basic programming. And each time we do this, I'm just appending that to a string, and then I'm going to print it to the screen, I think. That's all I'm doing with it. I'm not doing anything with that data. So I'm going to, in PD, if we look at my patch over here on the right, again, pretty epic. I just have a metronome. I'm modding that value from 0 to 127. I'm sticking it into this array of floats just to show that you can. So I'm going to send 1, 2, 3, 4 floats, and I'm going to format it and send it out to the right IP address and port. Nothing crazy. First, I just need to connect. Now I'm connected in PD, and turn on my metronome. So now it's just sending data every. Send a little faster. Why not? There we go. We got some data running. I think I changed something, so I probably broke it, but let's see. And there's our data coming in. So I think I changed it so I'm no longer sending that string at the beginning, which I said get me the string at value 0, but there's nothing there. So I'm just getting that array of floats, and we see here is the counter that I'm sending from PD. The rest were static values because I'm not changing them in PD. So now this data could be used for anything else, right? Every 10 seconds, make the ball jump. Sure, why not? It works just fine. Because this event structure in blueprints, actually for you guys left or right, can be triggered by any kind of data. So every time this hits 10, you can mod this value by 10, hit the jump key, or trigger the jump event, which we saw in the input at the beginning, right? So data coming from a keyboard, coming from my mouse, coming from my Oculus Rift, coming from OSC, it's all the same. You can trigger anything. And these all can run at the same time, right? This is still sending out, my output data, and I'm just printing it all on the screen because I can. Questions on that basic workflow, right? It's pretty straightforward. Again, it's weird. I get it. This is not something that you get used to at first. And to be honest, there's not a huge amount of documentation around OSC, as you would expect from a game engine, because it's primarily artists and musicians who use it. Whenever I search for it, I find images that I posted about 3 years ago about it on the Unreal forums, which is super annoying because nobody else has bothered to make any demos. So I'll probably share this on there because nobody updates their demo forums. But it's in the engine. It's great. The fact that that Epic is maintaining their own OSC library is unbelievably helpful because it used to be an external plugin that some random person in the world made, which was great. But every time Epic updated their engine, there would be a 3 to 4 month wait while this person, who may have been a student or could have been anything, got around to updating their code. Now it's part of the engine, which means it is reliable, easy to use, and it's safe to use in your projects and move forward. So for musicians, for artists, many of us working in these areas, this is a very natural workflow. Connect visual, interactive environment with audio engine, create, go forth and be merry. The very last thing that I wanted to show in this demo for you all, and it's very simple, so I can probably do it in like 4 minutes, is that there are these built-in synths in Unreal now, which is really cool. And for any of you who like classic analog synths and modular synths and that kind of thing, there's some really fun stuff in here if that's the world you enjoy. So in this case, just to point out where it is in here, I created a blueprint called Synth Actor. So here I made a folder called Synth, and this is just I went and said new blueprint, and it was just an empty blueprint, and inside of it there's very little code. That's the whole thing right there. Most of it is that one object. And on begin play, right, standard ID, I create. This is literally I'm instantiating a new synth. It's called a modular synth, and since I'm in a blueprint, I can actually add different components to the blueprint. They can be visual, or they can just be code. In this case, I go over here on the left, and I click Add Component, and I could just type synth here, and we'll see our options. Modular synth, granular synth, synth component tone generator, synth component mono wave table. These are, different synthesizer components. In this case, I'm using the modular synth. You could use the granular synth and play with that. A modular synth, so I created that, and just like in the level blueprint, we could see all the objects that were in the level. In this specific blueprint, I can see all the objects that are right here in this component list. And sometimes in your blueprint, like in my quartet project, there's like 70 things in this list, right? All the different components of the instrument are here. So in this case, I can just drag the component into the scene, and now I have its reference, just like in the other blueprint. So now I can do things with it. So here, I called set synth preset, which is, it essentially lets me create this, which is all the different parameters of a synth. Now, to be honest, this is a pretty ugly way to display musical control data, right? It's one giant game object thing, but it's all there. You can build a nicer interface, you can build a better way to do this data. I mean, it's oscillators, oscillator types, sawtooth, triangle wave, square noise, all the different parameters associated with each of them, LFOs, panning, frequency, right? All these different things you would expect. So this creates the synth, and then all that we're going to do to it is essentially give it messages that are very familiar to anyone who's ever used a MIDI system. Node on, node off. And in this case, when I press the 1 key, it's going to trigger node on at a certain node value, which I'm actually getting from that OSC input. So as I hit it, it'll increase. And then I hit it again, and it turns the node off. That's the whole paradigm for how to control these synths. And you can then map it to a keyboard, you can map it to anything you want. So, yep. This is it. We're at the end. You can hear it, it's really quiet. On, off. On, off. And I just set some random value in the modular synth. You hear it changing as that flow value is getting higher from my feedback. That's it. So that's just a basic, straight up modular synth running in Unreal natively. Receiving data from OSC, sending data over OSC. See you.